what we are supposed to do today. Briefly, we went through the introduction. So today we are going to zoom direct to the next thing we are going to do. We briefly look at what differentiation is. We said that this differentiation that we are looking was once used by Isaac Newton, which is a scientist and economics at the same time, when he was looking at movement between functions. Okay, he wanted to look at when there's a system of equations or functions, how these systems changes over time. Then he stated that the two main components when we talk about calculus is the differentiation and integration. So we use them in application in so many fields. We can use it to study the changes in our dependent variable when our independent variable also change. So we can use the differentiation to also do that. We can also use the differentiation to also determine whether your function is maximum or minimum. Now, the next thing we are going to look at is the tangent lines and derivatives. So when we talk about the tangent line, it's a line that touches a surface of a circle. Okay. Now, when you are finding the slope of a straight line, you have this line. You have this line, and you are finding the slope of this line. This is y, this is x. Okay. If you are finding the slope of this line, you can simply look for two coordinates. So x1, x2, y1, y2.
Sir, please.
Yes. Hello.
Sir, please. The slide isn't showing at my end.
Your line is breaking.
If it's from my side or the general thing. All right.
Can anyone confirm?
I was saying that the slide isn't showing at my end, but it's now showing. Thank you.
Can anyone confirm that?
So it is showing. Check your network.
Yeah,
so
it's showing now.
Let's check your network. Okay. Now, I was saying that if we want to find the slope of a straight line, we always find coordinate. Then we use the formula slope. The slope is what? Change in y over change in x. Change in y over change in x. That is what we use to find the slope of a straight line. Where this one you can say y1 or y2. You can say y2 minus y1 all over x2 minus x1. This is for a straight line, this line. Okay, so if you have values here, you can quickly calculate the slope. But how do you find the slope of a cycle? Or how do you find the slope of a tangent line? If you say a tangent line, for example, this is a tangent line. You draw a circle, and then this line passes through, touches the surface of the circle. This is a tangent line. Another example is the baguette line and then the indifferent curves. This is a tangent line. Okay, so this line is tangent to the baguette line. So at this point, it tells you that the baguette line and the indifferent curves are parallel, they are equal. Okay, and then in this point, they're also telling you that the circle and then the straight line are also parallel or equal. Okay, so how do we find the slope at that tangent point? This small point here, how do we find the slope? It becomes very difficult for us to find the slope under that point. It is very difficult for us to do that. How do we look at the changes? We know that we're talking about differentiation or derivatives of a tangent line. We are talking about how the functions or the curve changes. So we'll look at the straight line for this, for instance. We want to look at the changes. So we'll look at the changes between y2 and y1 divided by yx2 and yx2. We are looking at how the functions or the graph changes over time. But if you have the tangent line like this, which is a point, how do we find the slope? So it becomes very difficult for us to find the slope of this tangent line. So what we do is that we look at two possible points. Remember, when we are finding the slope, we need coordinates. We need 4 coordinates. Okay. So here, I want to assume that, yeah, I can find 2 separate points from here, x. So if I trace this one and trace this one, I can find x and y. So I have to say that I want to find my first coordinate. My first coordinate, I will have to say A. A is my first coordinate, and A, I can say, is the same as my x1. So that point is lying below here or within here. Then I can also say that let f of x or f of A be my y1. So it's like I'm finding 2 coordinates. I'm using different variables to demonstrate them or to represent them, because this tangent line is too tiny that you can explicitly find the value of the x and y value there. So I'm going to use any point, only tiny point within that point to also show them. Now, what will be my x2 and y2, and then sorry, x2 and y2? Yes, what will be my point? Now, I am also going to say that we are looking at changes over time. Okay, so let's assume that the changes takes place when I move a little bit, within this point. Okay, so let me say this point is h. So the difference between the two and this point is a. They are too tiny, we cannot find them. Okay, so my next point is that I want to add the changes in h to the a. So my x2 will going to be a plus h, and then my y2 is going to be f of a plus my h. Okay, these are 2 different points, y1, x1, x2, y2. Okay, so after I am able to specify this y1 and all the 4 coordinates, I can now use the formula of the slope to see how I'm going to get them. The slope is this formula here, y2 minus y1 over x2 minus what? X1. That is the formula we are going to use to find the slope. Okay. Now let's move on. Let's move on and look at the slope. We are using the same formula. Okay, so let me write it here. We are using this formula, y2 minus y1 all over x2 minus, sorry, x2 minus x1. Yeah. Okay, this is the formula we are going to use. So here, where is our y2? Our y2 is this. So I am going to write f of a plus h, f of a plus h minus y1. My y1 is this one. My y1 is f of a. Then all over my x2. My x2 is what? A plus h minus my x1. X1 is a. This is the slope. We are just substituting the value of x1, x2 in there. When you do that, you can clearly see that this a here and this a here will vanish. They will go away, so that we can get our formula to be this f of a plus h, then minus f of a. And this is all over h. This is all over h. Now, it means that this function here depends on the value of h. This function here depends on the value of h. Remember that we are looking at the line, the slope of a tangent line, which is one, gets a point within this cycle. When the straight line is tangent to any straight or any cycle, we are looking at the point where they are tangent, they are equal. So how do we find that point? Okay, so we are going to say that this function that we have got here depends on the value of h. So we are saying that as h approaches 0, this function become close to that particular point. This function become close to 0. It is reducing and reducing and reducing to what? To become close to that particular point. Okay, so we just say that the limit at which h approaches 0, then this particular point is going to be closer to that particular point that we are looking at. So this is the slope of to find the slope of the tangent line. This is the general formula that we are going to be using to find the slope of the tangent line. There if we move further, you get to know that when you use the normal differentiation and we use this slope of the tangent line to do the differentiation, at the end we are supposed to get the same answers. We are supposed to get the same answers. So this is the what we are going to use to be calculating the slope of a tangent line or the slope of an equation if we are being asked to do so. So please, let's take note of this. I'll take you through how we are going to derive this. So get familiar with this as we move on. Okay, so sometimes we want to simplify things, so we can say that if a function is approaching a, or if the variable approaching a, what will be the dynamics surrounding the slope of the curve? Okay, let's put this into practice by looking at a simple example. We are saying that let a be any real number. If a is any real number, then we can find the equation of a tangent line to the graph of. So the graph is this. This is the graph. Where a is at the point where we have a to be equal to what? X is equal to x, a. So this what? Tangent what? Line, or we can find the equation of this line. Now, there's two ways of doing this. We know that if we want to find the equation of a line, we all know the formula that it is a y minus y1. You can use this formula, y minus y1 to be equal to m bracket x minus x1, right? Minus x1. So this is the formula that we always use, or we use to find the equation of a line. Now, before you use this equation, then you might have given two coordinates. You might have been given two coordinates, x1 coordinate and y1 coordinate, so that you can find the slope and you now substitute it in there. Now, from this function, what will be the slope of the function here? What will be the slope? You can find the slope using two things. We can use the slope of the tangent line that we have found to find the slope. Remember that. Let me use that one then. Okay, let's hold on that one. Then when we get further, we can now be using them to find the slope. Now, how do you find the slope here? When you differentiate this one with respect to x, then that will give you the slope. When you differentiate this one with respect to x, it will give you the slope. We all know how differentiation is made. When we go further, we are going to do more on differentiation. So whether you understand how to do this differentiation or not, we are coming to do more differentiation here. Okay. So when you differentiate this function with respect to x, we are going to get 7. So the slope, which is equal the same as the m, is equal to 7. Please, if I'm going and you have a question to ask, just stop me and ask, because I will not see you. If you raise your hand, I will not see you. Okay. So why m is equal to 7? The slope is equal to 7. Okay. Then let me go back to the initial one. When I was driving the equation, I said that let x1 and then f of a be our second function. That is y1. Okay. So we are going to imply this one here so that we know our y. So y is equal to y1. y1 is f of a. So y1 is our f of a. F of a is equal to m. I said when you differentiate this function, you are going to get 7. So the slope is 7. So m is equal to 7. Then bracket x1 minus x1 is here defined as a. x1 is a. Okay. So x1 is equal to a. So when you have something like this, I want y to stand alone. So I will move this one to the other side and let y stand alone. So y is equal to 7 bracket x minus a plus f of a. F of a. Now, let's open the bracket from here. You can open the bracket here. So y is equal to, if you open this bracket, 7 multiplied by x. So 7x minus 7a. 7x minus 7a. F of x, right? F of x. Now, if look at this carefully, we are saying that this f of x is being defined. This one has been defined as what? F of x is equal to 7x, sir. This f of x, this one, let's look at this one. Look at how they define here. F of x is equal to 7x plus 3. And we are also stating that our x here is equal to a. X is equal to a. So it tells you that wherever you see x, you are putting a there. From this function, wherever you see x, you put a there. Okay, so it means that this function, we can rewrite it as f of a is equal to 7a plus what? 3. Because we are saying that x is equal to a. X is equal to a. So we can now substitute this one, f of a. Remember the equation that we have f of x there. So we have f of a there. This one is f of a. This one is also f of a. So wherever we see f of a, we substitute it. So we are now coming to have y to be equal to 7x minus 7a plus f of a. F of a is now 7a plus 3. Okay. So in that case, our equation become what? Simple. See that this 7a and this 7a can go away. So our final equation of the tangent line, which has been stated already, is equal to what? 7x plus 3. This is what was the slope of the tangent line. So they were asking us to guess, confirm that the slope of the tangent line when x is equal to a will give us this equation. And that is what we get demonstrated. Okay. So as we move on, we're looking at how to apply the formula to what? Find the slope of a line. The slope of a line. Okay. Now, yes, this is what we just done. Finding the slope of confirming the slope of the bagel line that we've gotten. Now, moving to the derivatives. We are going to be using this function a lot. So from here, we are going to be using this function, and we know where these functions came from. From the beginning of the lecture, I demonstrated how we can derive this formula. So please take note that we are going to be using this one as we move on very, very soon. So either we use this one for the derivatives, or we use this one for derivatives. Okay. But this and this are not different. This and this are not different. They are getting the same format that we are going to use. But we are going to be using the up one mostly. Now, how do we find derivatives of a function? We are going to look at these 4 steps. We are going to look at these 4 steps in order to enable us to find the derivatives of the function. We are going to look at these 4 steps. First, we are going to find the value of x, this one. Remember, the first thing in the formula was f of x plus h. So you need to find that one first. Now, when you find that one first, then you find your f of x plus h minus f of x. So the f of x itself is the function. So when you are able to find them separately, then you can what? Subtract them and you divide by h. Then you assume that when h approaches 0, then the function, what will happen to the behavior of the function? It is going to be closer to the limit. It is going to be closer to the tangent. Okay, so let's look, for example, then see how we are going to do about it. So here we are saying that f of x is equal to x squared. Now we are using the formula f of x plus h minus f of h all over h. This is what we are going to use. You know this, the 4 steps that they have given us, we are going to use that one to find the slope. To find the slope of the tangent line. Okay, to find the slope of the tangent line. Now, this one, we are just finding the slope. We are not finding an equation. We are finding the slope. Now, if you are use different method, if I want to use the normal differentiation to differentiate this, those of you who know about differentiation, before we even get to differentiation, if you want to differentiate this one using the normal differentiation, who will get that? Who can help me? When you differentiate x squared, what do you get? Those who know differentiation.
1.
It's not 1. Come again. Yes. Those of you who are differentiated before, when you differentiate x squared, what will you get? No one can tell me.
You get 2x.
Yes, you get 2x. Yes, you get 2x. You get to know when we are doing the differentiation itself, you get to know why it is 2x. But basically, when you are differentiating this one, we are going to get 2x. 2x. Yes. So let's take note of the 2x we have gotten. We are going to use this one. We are going to use this formula to also get the same 2x. Also get the same 2x. So let's take note. And then we'll see and follow how we are going to do that. Okay. So first of all, we need to what? The 4 steps that we have gotten. First of all, we need to find our f of x plus h first. This is what we are going to find first. Now, what is f of x plus h? This one is the same as your x. The whole of this one is the same as this x here. This one. That's the first thing you need to identify. First, this f here was representing y1. So here we can say that this f of x here is the same as y1. Y is the same as y is equal to x squared. Okay, so the whole of x plus h is the same as your x squared. It's the same as your x squared. Okay, so let's take note. So anytime you see x plus h, you are substituting the x squared there. You are substituting the x squared there. Then we minus what? F of x. Obviously, the f of x is also defined as what? X squared. Okay, so you just have to do your substitution and all over h. So here, let's do the substitution and see what we are going to get. Now, I'm saying that anytime you see x, it is your f of x plus h. So how do you substitute x squared into f of x plus h? So there's a square there. The only thing is that you are going to get x plus h. This one and this one, I said this one is equal to this. So once this one is equal to this, the only difference is that it's squared. So you just have to square this one, and you are good to go. Now this one, it is f of x plus h. We have done that. Minus f of x. The f of x itself is x squared. So you write the x squared itself there. Then you divide by what? H. You divide by h. So in that case, you can expand this. In that case, you are going to expand this. Remember, if you have x plus h squared, x is the same as x plus h, and then s plus h 2 times. Yes, difference of 2 squares. It's the same as this. So that you can expand this. We can expand this. Yeah, let's expand it. You are going to get x squared plus x plus sh plus sh again plus what? H squared. We are just expanding it. We are multiplying this one by this one by this. You multiply this one by this one by this again. This is what we are going to get. So at the end, you are going to get 2sh plus our h squared. This is what you are going to get at the end. We are just expanding the bracket here. So when you expand the bracket, then you come and substitute it there. You are going to get x squared plus 2xh plus h squared minus our x squared here now. This is our x squared. So minus x squared all over our h. All over our h. Now, when you do this, I can see that x squared here and x squared here, I can quickly cancel this and this here. So that h plus my h squared all over what? My h. Now, if I have this, it means that we have h here, I have h here. I can simplify my h out. So I have h bracket 2x plus h. I have factorized the h out. The square will not be there again. So if I have something like this, then I can quickly say that this h here and this h here will cancel out. What is left is what? What is left is 2x plus my h. And remember, we said that as h approaches 0, as h approaches 0, what will be the slope of the tangent line? So it means that when you put h, when h is equal to 0, when you put h is 0 to where the h is, so you are going to get 2x plus 0. Now x is up. We are saying h approaches 0, so h is equal to what? 0. So if h is equal to 0, we are getting the slope to be equal to what? 2x. 2x. And that is why we are saying that whether you use the normal differentiation same answer, and that is what we have demonstrated. Now here at the point to 1. Please, if you have any concern, always let me know that so that we can move on. So using the formula here, we can clearly see that the slope is equal to 2x, but when x is equal to 1, then our slope is going to be what? It's going to be 2. And that is what we have also gotten here. So sometimes you need to find the slope first before you can substitute the values inside. Now, this is another example. I hope you are following.
Yes, sir.
Okay. This is another example. Here, we are saying that if f of x is equal to 2x squared plus x plus 2x plus 3, we are going to find an equation of a tangent line to the graph at the point where we have x equal to y, x and y is equal to 7. These are two coordinates, so we know the coordinate. We want to find the equation of a straight line. We need the slope, so we need to find the slope first. Remember, they are going to use this formula. Y1, sorry, y minus y1 to be equal to m bracket x minus x1. This is the formula we are going to use. But we need to find the slope, which is m. From this equation, we have to find the slope. So how do we find the slope? We are going to use the equation of the formula to find the slope. So first, we are going to find the slope by using the formula f of f, that is x plus h minus f of a, f of x all over h. So we are using this formula to find the slope here. Now, how do we find the slope here? We are saying that everywhere you see x is the same as this. Everywhere you see x, you substitute this one there. Okay, so I've seen x here. I've seen x here. So I want to substitute this one in there. So I am going to get x plus, sorry, the first term is the first term is 2, right? The first term is 2x. So in that I am going to separate 2, then I'll put bracket x. Now the x is now x plus h. So x plus h. And there is a square there. So I write square there. Then plus 2x again. So I'll separate the 2 again. Then I'll write x plus what? My h. And then I'll close the bracket. Okay. Then this is plus 3. So plus 3 is there. So write the plus 3. So this one, the whole of this one is our x plus f of x plus h. Now we will now minus this from our f of x minus f of x, and then f of x is the whole function. F of x is the whole function. So you are going to write 2x squared plus 2x plus 3 plus 3. This is what we have. Then the whole of this one over h. So this is what we have. So we can, if we have this one, we can now simplify them. Remember the first time we expanded, I'm not going to expand it again. We have x plus h all squared. I expanded it in the initial. I expanded this one in our earlier one expansion. So I will not do it again. So if we expand this one, we are going to get 2 bracket x. Sorry, let me expand it straightforward. We're going to expand it straight away. So I'm going to get x squared plus 2xh plus my h squared. I've expanded. Close the bracket. Sorry, don't close. It's going to be, yes, please close the bracket. Then plus this one too. Let me open this bracket. If we open this one, we are going to get 2x plus my h, 2h. Yes. Then minus x squared 2x squared. This one is minus, so we are multiplying the minus inside. All of this will tend to negative. So here minus negative 2x minus 3 all over our h. So I want to hold on. I want to simplify this one first before I divide it by h. Now, if you have this one, we can simplify this. Let's open the first one. Let's open the bracket.
Sir, please the plus 3.
Sir,
Sir, you have omitted the plus 3.
Yeah.
yes.
Come again.
The 3. The first function. The
Yeah.
3.
The first 3.
Here the plus 3 should be. Yes, so plus 3 should be here. Yes, I think it should be here. Plus 3 should be here. Yeah. Yes, so it should be here. No, sorry. I'm coming.
Sir, it will be after
The
plus
3 should be
2h. After plus 2h.
yes. Yeah, it should be here plus 3. Yes. Thank you for that notice. Okay. So here we can, let's open the bracket here. You open the bracket, you are going to get 2x squared plus 4x h plus 2h squared, then plus 2x plus 2h plus 3 minus 2x minus 3 all divided by h. But I want to simplify it first before we can divide. Now, when you look at this one, there's some common numbers we can cancel. This 2x squared, and then this 2x squared can go away. And then 2x here can also go away. This 3 here, and then this 3 can also go away. So at the end, we are going to have 4sh plus 2h squared plus what? 2h. This is what we are going to have all over h. All over h. Now I have h here, I have h here, I have h here. I want to simplify, I want to factorize h out. So let's factorize h out. So I'm going to have my h outside. Then 4x plus 2h plus my 2 all over h. All over h. So if I factorize h out, then it means that this h here and this h here is going to go away. Let me clean some parts up here. I hope you are also writing something as I do. Don't just be listening and don't be writing notes. Okay, so we are going to have 4x. After canceling the h out, we are going to have 4x plus 2h plus 2 all over what? My h. Now I am going to assume that h, as h approaches what? 0. When h approaches 0, then we are going to put 0 wherever we see our h. Sorry, this h has cancelled it, has cancelled the other one down there, so we don't have it again. Yeah, so we are saying that we are going to say if h approaches 0, what will be our slope? So wherever we see h, we put 0 there. So we are going to have 4x plus 2 bracket 0 plus our 2. So finally, our slope is going to give us 4x plus 2. 4x plus 2. Remember, we are going to find the equation of the straight line. Don't forget this one. We are going to find the equation of the straight line. Okay. But they have given us the value of x and y. So when you find the slope to be 4x plus 4x plus 2, it means that we can substitute the value of the x there, then we can get the slope. So when x is equal to 1, from the question here, x is equal to 1, we substitute x there, we are going to get x to be, the slope to be equal to 6. Because we are substituting the value of 1 into the formula, you are going to get 6. Now we know that our m is equal to 6. If our m is equal to 6, what do we do next? If our m is equal to 6, we can now find the equation of the straight line. Let me clean this portion again. So these are just example. I'm so just more examples and solve. We might not be solving all examples here. So from here, I will not solve any example concerning this again. Now from here, they are giving us 2 coordinates. Remember that we have our m now to be equal to the slope, which is equal to 6. We have our 2 coordinates, 1 and 7, as given in the question. The coordinates are given here. So we are now going to use our formula there. Y minus y1. Y1 is our 7. So y minus 7 is equal to m. The m is 6. So 6 bracket x minus 1. Because x here is 1, y here is 7. So we are just substituting them into the formula. So we are going to get y minus 7 to be equal to what? 6x minus our what? 6. So you now come to group like terms, make y the subject. If you make y the subject, you are going to get y to be equal to 6x minus 6 plus what? Our 4. Plus our 7, right? 7. So our y is going to give us 6x plus what? 1. So this is the slope of the tangent line. You see this small question they've asked. See how you have gone around to find the equation. So this is the final equation that they need. Now, if we didn't want to go through a lot of stress, we can use, instead of using the equation, the formula that we use to find the slope, you can use the differentiation formula to get find this. Now, if you know differentiation, if you want to differentiate this one, you are going to get 4x plus 2. Simple. 4x plus 2. And that is exactly what we use the other formula to get. Okay. So you can just use the slope to the differentiation to get find it, and substitute the value of that, then you find the equation of a straight line, and you go away. So this is what we have done. We are able to find the equation of the straight line. And you see that in the slides, they will not expand everything. They will not go through you everything. They are just giving you something that you need to know. So if you are not taking note and you are just watching, when you are revising, you may find it difficult to recap what we have learned. There are a lot of examples. This is another example. Please, when you go, try this example. I will not try it with you. Example, the solution is there though, but when you go, try to solve it yourself. Now, let's put this one into practice. Let's put this one into practice and look at finding the average velocity of a function. So when we talk about the velocity, we are talking about distance and time. So we can use this one to find the velocity. Okay, so here, let me just add that here we are given change in S over change in T. It is talking about, it's the same as change in Y over change in X. We are looking at the changes, the distance that you have to use time to cover. Okay, and we define it as T and then change in T minus FT all over change in T. The change in T here is T1, or we can say T1 minus T2. Sorry, T1 minus T2, or T2 minus T1. It's the same as the changes. So we give you time in particular period, and then another time in another particular period, and ask you to find the change. You guys have to do the subtraction between the two periods, and that will give you what? The change. Okay. So we can do that by looking at the example here. They are saying that suppose the position function of an object moving along a number line is given by S. This is the position function. It's given by S, the distance, where T is in seconds and S is in meters. That's distance. We are going to find the velocity, the average velocity over the interval. Find the average velocity over the interval. The interval is between 10 and what? 10.1. 10 and 10.1. So the 10 and 10.1 will tell you something that we want to look at the changes. We want to look at the changes between this time period. So we'll look at change in time first, change in T. Look at change in T. So the change in T is going to be T2 minus T1. The current minus the previous. So the current one is 10.1. 10.1 minus 10. That will give you changes in T. And that is going to give you 0.1. That will give you the changes. That will give you the changes. Okay, 10.1. So what you need to do is that after finding the changes here, we just have to substitute it into the formula. What is our T? T is 10. T is the in this one 10. So we are going to have 10 here plus change in T. Change in T is 0.1. So 0 plus 0.1 all over change in T all over 0.1. That is all that you need to do here. Nothing but nothing less. See, you guys have to substitute the value of T there, which is this one, and you substitute the changes there, which is also this one, and you subtract T. F of T is 10. So that's the 10 here. Then you try to simplify it, and we are going to get 60.3 meter per second. Now you can also use the second question is to find the velocity. This one is to find the velocity when T is equal to 10. So what you do is that we are going to use the formula that we have found, the limit formula from here. You can try it home. You can try this one. Okay, so here I was saying that for this, the second one, they're asking you to find the velocity when time is equal to 10. So what you need to do is that we are going to use this one. We are going to differentiate the velocity. We are talking about just changes. Okay, we are going to use either this formula, or you use the formula that we used initially, or if you know how to differentiate, you use that formula and get substitute the value of t there. Okay, so here we are going to differentiate with respect to t. If you are going to differentiate with respect to t, you can use the formula that we've been using, or you can use the normal differentiation, and you are going to get the same answer. So if you differentiate this one with respect to t, we are going to get 6t. So here the differentiation is that you are going to multiply 2 by 3 and subtract 1 from the 2. Multiplying 2 by 3, you are going to get 6. If you subtract 1 from the 2, you are going to get 1. So here it's become invisible. So when you are able to differentiate this one, we are saying t now is equal to 10. So wherever you see 6t, so it's now going to be t is equal to 10 here. And that's going to give you 60 meters per second. We are going to do the differentiation more. So when we get there, you will understand how we get it. Okay. So you guess this one, they are just asking you to differentiate it. And then you substitute the value of t there, and you are good to go. So let's take note of them. Now, when you have been you've been given a graph or an equation, and you ask to find the limit. So here it is not something we should worry ourselves about. Here for A, they are saying that we should estimate the limit as x equal to 1. So let's go to the graph. Then you look for where x is equal to 1. This is x. This is 1. Okay. So you trace this one to the y-axis. Then you trace it down there. You are going to get the limit to be equal to 2. So it's not something you should worry about. So you just use this one to find the limit. The same thing here. You just come here, trace this one to this, and you trace it to 2. So these are, I guess, something you need you to bother yourself about. Now, what are some properties of the limit? Some properties of limit. There are some property of limit that we are going to do. If you take a limit of a constant, we are going to get a constant. Take note. A limit of a constant is going to be a constant. Remember, when we're looking at the function, we said that the limit as h approaches 0, if you have 4x plus h, and I said the limit as h approaches 0, it means that whenever h is equal to 0, you are going to get 4x. You are going to get 4x. But if you have a constant, let's say you are having limit as x approaches 5, then you have a function. Let me use this one 2, and you have a function to be 4x. What this means is that we are going to be substituting the 2 into the 4. That will give you are going to get 4 with 2, and that will give you 8. Okay, but if you have a limit as x approaches 2, and you have 100, what will be the final answer? Who can tell me? Yes.
So,
200.
please,
Come again. Maybe you are not seeing it. Well, let me write it well for you to see. I'm saying that you have a limit x approaches 2. You have 100. What will be the answer? What will be the limit?
Say 100.
Yes, it's going to give you 100. So here, that is what the rule is saying. The limit of a constant is the same constant. The limit of a constant number, because there's nothing variable here. There's nothing x here for you to substitute. So the limit becomes the same thing. So that is the first rule. And then the second rule is that when you have the limit of a number, for example, you have, take note of how it's done here. Take note of how it is done here. Okay. So this x here will come and raise n, where this one become invariable. So here, if you have a limit at, let's say, x approaches 6, and then you have 2 here. What this one is meaning that it's telling you that it's going to give you x what 6 raised to power 2. 6 raised to power what? 2. So this rule is also another rule that we have to take note of. And whenever you are asked to do it, please don't always forget. It's a rule. It's a rule. Don't forget how to do it. So you just look at how the rules is and then apply it in the real thing. So here the a is coming to raise up the n. So here, if you have the limit at which s approaches 6, the 6 is just coming to raise up to the what? 2. Then you get your final answer. So let's take note of the limit. Okay. So we look at the third limit. The third limit, or the third rule. The third rule is also saying that if we are adding or subtracting 2 limits, you have to be explicit on them. Don't lam them up. Don't lam them up. Separate them nicely. You see, this limit here is standing alone, and you have a bracket, right? You have this bracket closing them. So if you are adding them, you have to apply the limit to each of them, to each term. So here become limit, and here become what? Limit. Don't put the limit in the bracket. That's the second rule. So you just have to separate the limit and multiply and add or subtract them. In the same sense, if you are multiplying them, the limit, you don't have to do this again. Open the bracket and make sure that the limit is applied to each of them. That is the fourth one. Then the fifth one is saying that, also saying that if you have a constant, so you have 20 and a function of x, and you are applying the limit this way to all of them, it is not appropriate. It's not appropriate. So separate them, because from the beginning we said the limit of a constant is the same constant. So it means that it becomes unnecessary if you apply the limit to a constant. So better separate the constant. And you apply the limit to the function. Just separate it. And that is what the fifth rule is also saying. Okay. Now we have the quotient. This one, the same.
Sir,
yes.
With the last example, it means the constant is multiplying the function, or?
Yes.
Okay.
The constant is multiplying the function.
Okay.
So if you are applying the rule, separate the constant.
Okay, sir.
Yeah.
All right.
Now the sixth one is also another one. If you are using the limit, you guys don't have to say limit f of x plus g of x. No, limit. Apply the limit to each of the terms, up and down, before you divide them. And you have to also take note that the limit of f of g should not be equal to 0. If it is equal to 0, then this function becomes infinite. This function becomes inexistent. It won't exist because we are dividing any number by 0. Even the mass will give you what? Undefined. So we take note of that. Now, if you are also taking the radical or the square root of a number, this is also important. The square root of number, the limit shouldn't be outside the square root. The limit should be inside the square root. That is another important point we should also take note of. And these are some small examples about the limit. Small example about the limit. The first one is a constant. When you take the limit of constant, you are going to get constant. The second one is being clear that if you are having the limit of x, the limit of x squared as x approaches 6, you have to know that the 6 here will come and raise to the power 2. And that will give you 36. Don't forget, these are rules. You have to follow them. And the same thing approach is a function of this as well. Okay, so this one is going to give you 2 raised to the power 4. 2 raised to the power 4. And you are also going to get your 16. So take note of the function, how the root, how the...
And so, with the
Yes.
example C, you know, they made it limit as t approaches 2, but here is -2.
Don't worry, maybe it's a typo. Don't worry about it.
Okay, sir.
Yeah, it's a typo. Okay. Now, let me move quickly to this. No, this is not necessary. Yes. Let me move then to finding the limit itself. Finding the limit. So from the rules, we can find the limit when we are being given a function. Here, you see, when we are given the function, they say if you are going to do, you should make sure that the limit is applied to both sides. So you have limit x, limit of what? X squared minus 1 over limit of x plus what? 1. Apply them both sides before you can simplify, before you can find the limit as x approaches -1. Now, if you have x 2 minus 1, difference of 2 squared. Who can remember difference of 2 squared? How can you express this function? Which other way can you express this function?
So it will be x
X
plus
minus 1 to bracket, and then bracket open x plus 1.
Yes, exactly. So it will be x minus 1 and then x plus 1. Exactly. So you can express this one like that. You can express it. So you are going to get limit x minus 1, x plus 1, all over the limit x plus 1. So we can clearly see that this one of them will cancel this, so that we will have our limit x minus 1. So the limit as x approaches -1. So wherever we see this, we are going to put -1 there. So we are going to get -1 minus 1. And that is going to give you -2. That is the limit. And this is what they are asking you to find. Not anything before. Okay. Now, what about the second one? The second one, we are going back to what we have been doing earlier. So here they are saying the limit as h is equal to 0. So you know this formula, right? You have to apply this formula to get the answer. You have to apply this formula. If it were to be face to face, I will let you work it for me to see. I've been teaching this one on face-to-face, and once, well, if you are to face-to-face, I will let you work this one for me to see. You are fortunate. Well, I worked this one, examples on this one, so I'm not going to, when you go, you can try it yourself. Okay, so this is what they have gotten, the limit to be -2. And this one, if you also follow the formula and then expand it, do the cancellation, you are also going to get to be negative what? 2x. That's the slope. Okay, we continue to find the infinite figures. Infinite figures. So it means that there's some limit that when you take the limit, it doesn't exist at all. It will give you infinite, or you see whether it exists or not. Let's look at this. The first one. The first one. If you take the limit at x approaches -1, it's -1. Now, if you substitute x there, that will be -1 plus 1. What are you going to get? You are going to get 2/0. 2/0. If you put it in a calculator, it will give you mass error. So it doesn't exist at all. So there are some function, some limit that when they give you the limit to simplify, please always make sure that you look at all these things before you move on. Okay, so make sure that you look at all these things. If it exists, then you can go on. If it doesn't exist, you can just conclude from there. This one too is 2. 2 raised to the power 2 is going to give you 4. 4 minus 4 is going to give you 0. So the whole of this one doesn't exist. Doesn't exist. So two functions, both functions doesn't exist. If you want to look at the limit on those aspects, but there are some limit that will lead you to infinite. Infinite. Remember that we use this one to represent the infinite. This is the infinite symbol. Okay, so let's look out for this one, for example, the first one. They are saying that we have 4/x minus all the to the power cube. And here, as x approaches infinity. Now, when we say x approaches infinity, it means that as x increases, what will be the value? What would the function behave as x increases? So first, let's assume that x is equal to 5. Let's start from 5. So it means that we are going to put, if you put 5 here, you are going to get 5 minus 5. No, don't let us start from 5. Let's start from, let's say, any number. Let me use, if I use 5, it means that we have to go far. Let me start with 2. So if x is 2 here, then it means that we are going to get 4/-3 raised to the power 3. Then you get the answer. Okay. If x is equal to 10, f is equal to 10, we are going to get 5 raised to the power 3 all over 4. If s is equal to 100, we are going to get 95 raised to the power cube over 4. Now, what do you think is going to be happening? Because if as x increases, the whole function is becoming smaller and smaller and smaller. If you have calculator, you can try. You can try and see. If x increases, the whole function is becoming smaller and smaller and getting close to 0. Sometimes if you divide small number by a bigger number, you can get, example, you can get 0.000000012 or something. Okay, you are dividing a smaller number, a constant number, by a bigger and a bigger and a bigger number. It means that that whole function is becoming close to zero. It becoming close to zero. And that is the essence of us saying that as x increases, the value of the function becomes close to zero. As x increases, this one, the function here become close to zero. Become close to zero. Now, when you come to this one again, we are also saying that now as x here also increases, as x also increases, then this one become negatives. It become negative. It become infinite, negative infinite. It become negative what? Infinite, or it becomes something that we cannot think about it. Sometimes you cannot even define, because initially we said that when you divide a number by negative, it becomes imaginary what? Numbers. Calculator cannot even find it. It becomes inexistent. Okay, so as x increases, that number becomes infinite. Okay, so these are some of the things that we should also take note of. Now, these are some of the things that you can also take a look at. If x increases, what will be the value? When y increases, what will be the value as well? So these are some of the things that we have to be taken note of as well. So when they give you this one, try to even look at when x is increasing, what will be the value of the function? When x also increases to negative value, what will be the function? Okay, so it's going to give you a finite or infinite value. So let's go and see how we are going to look at that. Now, let's now move on to our main thing, derivatives. Derivatives, or the differentiation itself, derivatives. Now, before we tune into the derivatives, we are going to look at the symbols, or what you will see when we talk about derivative. What always come to your mind? What do you always see? The symbols to represent derivatives. This is one symbol, f of. If you see f prime, it means we are talking about different derivatives. If we see dy over the x, we are talking about derivatives. If we also see this, we are talking about derivatives. All this one represent derivatives, but what we are mostly using is dy dx, or x f prime. Dy dx or f prime. Okay. Now, the rules for differentiation. The first one is a constant rule. Constant rule. Now, the constant rule says that when you differentiate any constant, we are going to get 0. And we can prove that. But before we prove that, let's look at the second rule. The second rule is the basic for everything. The second rule is saying that if we have, let me write this one nicely here. I have ax raised to the power n. That is y is equal to this. I want to do it nicely here. A is a constant. X is a variable. And then n is also any number. So if they ask you the power rule, this is called the power rule. If you ask you to differentiate, the rule says that multiply the exponent by the whole function and subtract 1 from the exponent. So the rule says that you have dy over the x. You are going to get multiply the function, the whole function, by the exponent. That is n coming down to multiply ax. Then you subtract 1 from the exponent, so n minus 1. This is the basic rule, and this is what we are going to be using throughout. Anything you are given to you, you have to use this one. We are going to use we are going to look at a lot of examples on this rule, but you have to take note of this rule. This is the basic rule that you have to understand. When you understand this, the rest of the rules are not difficult. The rest of the rules are the same thing. The rest of the rules, just to apply them, then you are going. So here, if you have y to be equal to 2x squared, 2x squared, the rule says that multiply the exponent by the whole function and subtract 1 from the exponent. So you are going to multiply 2 by 2. That's going to give you 4. Then you subtract 1 from the exponent. And that means that you are going to get 4x. So anytime you have 2 raised to the power x, it means you are going to get 4x. If you have 2 raised to the power 3, it means that you multiply the 3 by the whole function and subtract 1 from the 3. That is going to give you 6x squared. Please take note. This is the basic. The rest of them are just following that. So I'm not going to worry myself on them. The most important thing you need to know is the power rule. Is the power rule, which you have known. So once you know the power rule, you can prove that when you differentiate any constant, it's equal to 0. Let's do that and move forward. Let's do that quickly. And then we'll move forward. We'll prove that when you differentiate a constant, you are going to get 0 using the power rule. The power rule is the basic for everything. So once you are able to understand that, the rest, I'll not waste my time there. But we are going to apply them. Now, if you have a constant, let's say 20. 20 is a constant. It means that you cannot differentiate a constant. You are going to get 0. But how is it 0? Now, we also know that any number standing alone, you can say that x raised to the power 0. Any number raised to the power 0 is 1. So if I put something like this, it's the same as 20, right? It doesn't make any difference. It's the same as 20. So I can now differentiate this one, say, by using the power rule. So dy over what? The x to be equal to, now the power rule states that multiply the whole function by the exponent. The exponent here is 0. So I'm going to multiply 0 by 20x and subtract 1 from 0. So I'm going to put 0 minus 1. And that will give you 0 multiplying by what? 20x minus 1. Obviously, if you multiply 0 by this function, you are going to get what? 0. And that's the reason why we are saying that when you multiply when you are differentiating a constant, you are going to get 0. The rest of the rules are applicable. We are going to look at example of each of them. Then you don't have to worry ourselves about. Okay. So from the above, we can now look at the power rule. We have the power rule. We have the multiplicative constant rule.
Hello, sir.
Yes.
Sir, please, this one is just an inquiry.
Go ahead.
I thought every number is having an exponent of 1. Because I know if we have 3, that means the 3 is already having an exponent of 1. So why was it that in this case, the exponent of x was 0?
Oh, this is from the rules, the indices, law of indices. Any number raised to the power 0 is 1. It's a law of indices.
Yes, sir.
Yes. So we are applying the law of indices to do that. Or if you even want to use that, if you even want to use what we are saying, I was saying that y is equal to 20. Right? If you don't want to use this one, if you don't want to use this one, you can also use what you are saying.
Okay.
So, yeah.
Yes, sir. I get it now. It now. Thank you very much, sir.
All right, you're welcome. All right. Any other question? So this is the simplification of all the rules, and we are going to apply them here soon. The constant rule, the power rule, which is the basis of everything. We have the multiplicative rule, That is when you are multiplying, when a function is multiplying by a constant, how do you differentiate it? When we are adding numbers, a constant plus functions, how do we differentiate? When you are even differentiating them, how do you also differentiate? So we are going to apply them and the rules are there. So let's look at how we are going to apply each of them. The first one is the constant rule. I will not explain that again. We know that if we differentiate a constant, we are going to get 0. So please take note of that. The second one is our power rule. The power rule here, they are giving you y is equal to 3x. So when we differentiate this one, what will you get? You now know how to differentiate. What will you get?
3x squared.
3x squared. Yes.
Yes, sir.
3x squared. Because we are saying that multiply the whole function by 3 and subtract 1 from 3. We are going to get 3x squared. What about this? This one is the same thing. It doesn't change anything. We have 10 to the power x. What do you get here?
30x squared.
30x squared. Exactly. Then you come to the third one. The third one is x cubed plus 10 plus 50. What will you get here?
3x squared.
3x squared, yeah. But when you differentiate 50, you are going to get a constant. You are going to get 0. Don't worry about it. Don't forget about the 0. What about the last one? What will you get? You have x cubed plus x squared. What will you get here?
3x squared plus 2x.
3x squared plus 2x. Exactly.
Yes.
So these are the basic things. Now you know what differentiation is. It's not difficult. No, calculus is not difficult. We just need them to apply them in economics. Okay, these are the answers. These are the answers that you can think of. So you can also make reference to them. So when it's 9:30, we'll go on break. And then we'll come back and then we'll continue. Is that okay?
Yes, sir. Yes, it is.
Okay. Now let's move to the rules of difference. These are very important rules. Very important rules. These rules are more than rules. Okay. I'll call them the type of differentiation or the kinds of differentiation. There are 3 basic kinds. Let me say 3 basic kinds of differentiation. We have what we call the quotient rule. We have what we call the product rule, and what we call the product rule, the quotient rule, and then the chain rule. These are the 3 basic rules that we need to know. Very, very important rules, and how we are going to apply them. Now, what is a chain rule? The chain rule is when you have a function within a function. When you have a function within a function, for example, you are having y to be equal to f of u. F of u. But u here is also a function of f of g, gx. You see that y is a function of u, and u is also a function of x. So it's a function within a function. So when we are differentiating this kind of function, you have to be very careful. We don't differentiate it anyhow. You have to differentiate the whole function itself. That is y first, and then you go inside there and differentiate respect to x again. So it is very, very important for us to differentiate these functions. So if you want to, in this sense, if you want to differentiate the x, the u over x, then first of all, you have to differentiate the y here respect to the u. And you differentiate the u here respect to the what? X, and multiply them. That is what the formula that we have. So if you have a function within a function, then you have to use what we call the chain rule. The chain rule. We are going to apply it very soon. So take note of that. Now, The second one is what we call the product rule. When you are having two functions multiplying each other, it is obvious that they are product of each other. So we cannot use any other function. We have to use what we call the product rule. The product rule says that you have to hold one constant and you differentiate the other one. Then you hold the other one constant and differentiate. So you differentiate and hold and differentiate. So this is what we are going to do here. This function, this is a product rule. So first, you have to hold u constant. So here you are now differentiating u, but you differentiate the v over the x. So we are now differentiating u. We are holding u constant and you differentiate the v. Plus, this time, we are not differentiating the v. You are holding the v constant, but you differentiate what? Your u over the x. That is the what? The product rule. We are going to look at example. Now, when you come to the 7 is what we call the quotient rule. In the quotient rule also state that when you are also doing the differentiation, you should expect a function dividing a function. Then you can you can use the quotient rule. So the quotient rule is coming to talk about fractions. If you have functions that are fractions, you use the quotient rule. So how do we also use that? This one also says that you hold one constant, you hold the denominator constant, the v constant. Then you differentiate the u over the x. Then minus, this time around, you are going to hold the u constant, then you differentiate the v over the x. Then you divide all by what? V squared. V squared. This is also another formula. We'll look at example and how we are going to apply it. Then the last is the inverse function. The inverse function. You guys take the inverse of the function, and that is what we are talking. You differentiate this one. You can differentiate and take the inverse of the function. So the inverse of the function gets taken the other way around of the function. So let's look at the example of the product. No, the chain rule. A function within a function. So here, here we are saying that y is equal to the whole y is equal to bracket x squared plus x 5x raised to the power squared. So it means that we have y to be a function, and y function is the one in the bracket with the squared. Inside this bracket, we have another function there. So what we are going to do, we cannot differentiate this one anyhow. We have to do a specific rule to differentiate this. And that rule is what we call the chain rule. Now, what do we do? The chain rule says that let u to be equal to x squared plus s squared plus what 5x. Okay, in that case we have our y to be equal to what? U squared, u to the power cube. So what it's telling you is that, you see, we are saying that there's a function within a function. You see that y is equal to u cube, and inside the u is also a function of x. So u is a function of x, and then y is a function of u. So there are two different functions within that are embedded in each other. So we cannot use any other thing. We have to use the product or the chain rule. So first, you differentiate the u over the x. The u over the x, what will you get? You are going to get 2x plus 5. This one, we are differentiating this one first. Then you also differentiate dy over the u. Dy over the u. That is going to give you 3u squared. 3u squared. Now, our task is to find our dy, over the x. If you want to find dy over the x, then it is going to give you our du over the x multiplied by our dy over du. Okay, so this is what we are going to get for here. So we have differentiated the du dx, which is equal to what? The u dx is going to give us 2x plus what? 5. And then we are also able to differentiate our du dy. The u dy is going to give us 3u squared. 3u squared. So let me rewrite this one nicely. We are going to get 3u squared multiplied by 2x plus 5. But we know that what is our u? Our u is equal to x squared plus 5. X squared plus 5x. So we can now substitute the u inside there into the formula, this formula, so that we are going to get 3 bracket x squared plus 5x plus 5x. Then you close this bracket, raise to the power 2, then you multiply this one by 2x plus 5. 2x plus 5. Now, this is what you need. If you want to go further, you can simplify it. Okay, otherwise, you can always try to leave it here. But if you want to go further, you can multiply this one inside, multiply this one inside. After that, you multiply them together and get your final answer. So this is how we use the chain rule to do the efficiency. So take note and follow the steps, how we are able to go through it. So if you follow the same thing, that the solution is here, don't worry, the solution is here. I was just demonstrating how they got the answer. Okay, so just make sure that you follow and then you go out to do it. Now, this is the product rule. Now, with the product rule, remember that let's also do the same thing. Let u to be equal to the first function, that is x squared plus 1. And then v to be equal to the second function, x cubed plus x squared. Okay, so that we can differentiate du over the x. Du dx is going to give you 3x squared. Then dv dx is going to give us 3x squared plus 2x. Yes, so we know this one. Now, what is the formula for the product rule? The product rule says that if you have u and v, you hold u constant, so u constant, and you differentiate v. So we have dv over what? The x. And you add it. Now you hold v constant and you differentiate du over what? The x. This is what we have. Okay. So once you know this formula, you guys have to substitute what we have done there. What is u? U is equal to x squared plus 1. You multiply this one by the differential of v. If you differentiate v, we are going to get 3x squared plus 2x. Then you plus the whole v constant. When you fold v, what you get? You get x cubed plus x squared. Then you multiply this one by the differential of u. you differentiate u, you are going to get 3x squared. This is all about the product rule. So it's not anything difficult. You just have to remember the formula. After here, you can simplify it, or else you can also leave it like that. And this is what we have gotten. This is what we have gotten. So take your time, go through them, and you'll be okay. The next one is the quotient rule. The quotient rule too is another example, another simple thing that we need to know. Let this one be our u, and let this one be our v. Our v. Okay. So if you want to apply this one, you have to differentiate. You have to look for the differential of u over dx. We have done it already. That will give you 2x. Then you also look for dv over what? dx. That will also give you 3x squared plus 2x. Plus 2x. Now, the formula says that if you have u over v, then it means that you hold v constant and you multiply, differentiate u over the x. Then you subtract here, we are now differentiating u, multiplying the v over what? The x. Then you divide the whole of this one by v squared. Okay, so you know your du dx, you know your v, you guys have to substitute the formulas inside, and you are better. You substitute the formulas inside, you are going to get what is v here without differentiating. V is 3x squared plus 2x. Then you are multiplying this one by du dx. Du dx is 2x. Then minus v. The v here is what? V here is no, sorry, u. You are taking u here, u. The u here is x squared plus 1. Then you multiply this one by dv. The dv here, when you differentiate the dv, you are going to get 3x squared plus 2x and you all over, sorry, this one you are this one. Okay, so let me rewrite it here clearly. So v, let's write the v here. The v is 3. The v is x cube plus x squared. You are multiplying this one by the du dx. Du dx is 2x, so 2x. You close the bracket minus. Then here we are going to write the u. Where is u? U is x squared plus 1. Then you multiply this one by dv dx. Dv dx is going to give you 3x squared plus 2x. And you divide the whole this one by v squared. What is v? V is x cube plus x squared. All over what? Squared. Okay. So if you can simplify this one, go ahead and simplify. You can. If you cannot simplify, you leave it. Okay. But this one, I think you can simplify it here. You can simplify this one. Just try to expand it. You see, this one and this one is the same. So this one and one of this one can what? Cancel out. Then you can do your simplification. So we have gone through the product rule, and then so the rest is something that we can now do on our own. So for this one, this one,
So
yes,
if I get you right, it means that the first one, that would be the y dx, and the second one is the u dx. Is that it?
hello.
Yeah, please, did you get my question? Hello?
No, I didn't get.
But please go
Come
back
again.
to the question. Yeah, the question we just solved right now.
Come again.
Yeah, this one, this particular one,
Yeah.
or the subsequent one. You mean when we want to differentiate, it means that the y dx is the first one. That is the numerator. The denominator is dv and the x. Is that the meaning?
Oh, you just have to follow the formula. You see, let me come. You just have to follow the formula. We are saying that for this one, if you have the quotient, this is the quotient rule. And the quotient rule says that if we have a number u over v, it's a fraction, and they're all functions. It's a fraction and they're all functions. You have to use the quotient rule. So you represent the up one by u. You represent the second one by v. So when you come to this 2, it's a fraction. While the up one was u, so you can also equally say that this function is u, and this function is v, so that you can follow the formula that is being applied to you to that.
Okay.
Yes. So sometimes it is not about follow u and v. You can use any variable. For example, if I say the quotient rule follow q over t, it also means that whenever I am going to use this one, it's a fraction. Okay. So here, if I'm coming to apply it to the fraction here, I am going to say that let the q be equal to x squared plus 1. And then the t should be equal to x cubed plus x squared. So that I can now use it to apply in the formula. Okay, so you just follow the format, the formula. It's not something that is constant. I hope you are okay.
Yes, sir.
Okay. So please, it means that you have to make sure the formula I guess in your fingertips. The product rule, the quotient rule, and then the chain rule, the formulas. Try to make them part of you, so that whenever you find yourself, you know when to use them and when not to use them. It's very, very important. Don't confuse yourself with the product rule and then the quotient rule. The product rule is when you are multiplying two different functions. So you use the product rule. The quotient rule is when you are dividing, or when you are talking about fractions, then you use the quotient rule. And then the chain rule is when you have a function within a function, then you can use the chain rule. Okay. Then this one is also the inverse, rule. Here you guys have to differentiate the function and take the inverse of the function. And you are better off. So so here we get differentiate the y over the x, which is going to give you 2x. So if we take, remember, any number standing alone is over 1. You take the inverse of this, you are going to get 1 over 2x. This is all about the index. So there's nothing to worry about this. Okay. So in 5 minutes time, we're going for break. We will come back for break. We're doing a lot of applications. Now, now let's look at application of rate of changes to economics. So we are here, differentiation, how we apply the differentiation to economics. We can apply it in cost function when we want to find total cost. You know that total cost is equal to fixed cost plus variable cost. We can apply them when we want to find marginal cost. When you differentiate the total cost, you are going to get the marginal cost. Okay. We can also use it on total revenue functions. When you have the total revenue, you can find the marginal revenue. You differentiate the total revenue to get the marginal revenue. Okay. We can use it in a lot of applications. We can look at how the percentage changes in the variable in respect to one variable. Okay, a lot of them. So when we come back, 5-minute break, or when we come back from the break, we are going to be doing a lot of these applications. Okay, so let me see, let me some 4 minutes. If I start this one, will I finish before the 5 minutes?
Please, let's go and come back and start with this one.
Okay. All right. So let's go. How many minutes do you want to go and come?
Give us 10.
Huh?
Doug, let's start at 9:40. It's almost 9:30. So let's start at 9:40.
9:40. So
Yes,
how
Doc.
many minutes?
About 6 minutes.
About 6 minutes.
Okay.
Who are different suggestions? Someone say we should come at 10.
Oh, we should come around 9:40. It's not bad.
Okay. Yes, so let's come around. Okay, let's come around 9:50. I will start 9:50. But some of you have to prepare some of you have to do some tea and those things. All right, see you after some 25 minutes or 40 minutes.
All right, sir.
Yeah. So I'm going to be off for this period. I will come back when we are the time is due.
All right, sir.